Henry Tam with Redis. I'm the Principal Solutions Marketing Manager for our AI and ML solutions. Today's topic is how to enhance your approach to generative AI, LLMs, your data, and of course, Redis as a vector database. Okay. Trying to advance here, sorry. All right, so quick agenda. I'm just going to cover large language models in very high level, some of the challenges with using LLMs in your generative AI applications, kind of a rethinking of what your data strategy should be, and then of course, how we make it faster and easier to deploy your LLMs with Redis Enterprise. So first, I'd like to start with kind of a trend slide. This is from Battery Ventures. I think the key point here is that I think we all obviously recognize the adoption of AI, how ChatGPT kind of hyper accelerated, this new classification called large language models. And so what we see here in this particular survey that Battery Ventures did was that just literally 6 months ago, only 32% of their respondents said that they were planning to deploy generative AI and large language models. It has dramatically doubled, more than doubled, to almost 80% of their enterprise surveyors or surveyed people that responded to their survey said that they're ready to plan and deploy generative AI and LLMs in the next 12 months. So it's obviously significant adoption happening in the industry. Just my quick high-level overview. Foundation models, very broad, general purpose, broad range of knowledge and capabilities. I think the evolution or the change has been the availability of these, what I like to call more large language models that are more tied to natural language processing tasks. So you have GPT, you have Llama, Falcon, etc. And the main distinction here is that this subcategory of foundation models called large language models has been trained on massive amount of text and information all across the public web, right? And so I think the first iterations I remember were a couple of billion parameters. I believe the latest models have literally hundreds of billions of parameters now, and they're really useful for a couple of tasks like semantic search, summarization, and extraction. And just to kind of dive a little bit deeper into some of the business applications that we see our customers and certainly what you guys are doing in your industries are things like taking some of your specific company data. If you're in a financial services part of the realm, or you're in bioscience or biopharmaceuticals, take your specific data and documents and leverage that to help with things like question answering, information extraction, and even content generation, right? So if you're in a, selling products both to business and or consumers, customer support, taking the information from your support tickets and using that to help augment your support agents or call center agents, product data for things like recommendation systems. All of these things are now made possible through these large language models. So I mentioned challenges earlier, so I want to cover just kind of the 4 broad categories. I think most of you may be familiar with this, but I think it bears repeating. Cost is probably one of them. There are obviously some use cases where you do want to train or fine-tune your own model. You want to be able to host your own model. Maybe there's a very specific subset of data that a GPT or Llama or any of these other large language models may not have been trained on. I mentioned earlier, a lot of the benefits of ChatGPT has been being trained on all of that wealth of public information. There's also a cost element in invoking the APIs to go to ChatGPT or any of the other large language models. So you pay by token, every API call, input and output has a cost associated with it. And then from a quality perspective, we talked a little bit about kind of the broad kind of knowledge that like a ChatGPT may have been used to train the model, and then the kind of very domain specific specialized knowledge, right? And so that difference between ChatGPT not having access to the specialized knowledge or your specific company data, obviously impacts the quality of the response that you will get from asking a question. And then, of course, there's the whole question of freshness. I believe ChatGPT 3.5 was basically trained on data from 2021. So there's also a freshness or a newness um, of the content as well. And then we all have heard the term hallucinations. This is where there is a risk that that particular large language model produces made up information. So not only is it probably not inaccurate, but it also can make up things as well, potentially, if it does not have the relevant context or information that was used to train the model. I think performance is clearly an issue. There is a lag in LM response time. I personally see it when I use the different large publicly available large language models. And so it does impact your end application, whether it's a chatbot or a recommendation system. It does impact the speed of the response. And obviously, the more concurrent users your apps have, it also will impact your throughput as well. And in the last area, I think, and I've done a couple of talks on this, and I typically get actually a lot of questions around security. And so it's the whole notion that, well, how do I, control, if I train this model with my data, how do I protect my proprietary information, sensitive information? I don't want to have any kind of PII information or HIPAA information kind of leaked out to the world. So the need for more strict, role-based data governance models. I think this is a recurring topic and concern for a lot of enterprises, especially the ones that are in the regulated industries that deal with these types of sensitive information, or even anyone that has proprietary information, right? So these are the four challenges. And so where does vector databases come in, and how do they complement some of these challenges with large language models? And so, Redis, for those that are not aware, does support vector data types and does support vector search. So that's where we play. And I'll go into a little bit of what Redis does in a couple of slides. But I really want to kind of restart from the groundwork of kind of thinking about your data strategy when it comes to large language models. The number one thing that we've heard from customers is they want to use these public large language models like ChatGPT, but they want to be able to leverage their private company specific or domain specific data. That's probably the number one, I think, request or business requirement that they have. And so we talked already about how then that brings up the issues of data privacy and data quality. And so, I talked a little bit earlier about you certainly can fine tune some of these models or retrain them. But we talked a little bit earlier about some of the costs involved. And again, this is going to be case by case specific, right? Certainly for specific verticals or areas, it may make sense to fine tune an existing model or retrain an existing model. And then, of course, the other issue is safeguarding that sensitive data to do the fine tuning and retraining. So one of the things that we want to also consider when you're thinking about your data strategy is the idea or notion that, well, why don't we just put all that data that we have into the prompt? That way we are not fine tuning or retraining the model. We're still using that SAS API for that publicly trained LLM, but we're going to put everything into the prompt. Well, I think I mentioned earlier, right? A lot of these LLM providers charge per API, charge per token. And there's a limit to the amount of tokens you can put both from the input and the output side. So, it ranges from, I believe, like ChatGPT 3.5 had a 4K limit. I believe GPT-4 has a 32K limit. So that's not a lot of information that you can feed into the prompt. So really, this is, again, what I'll share is what vector databases can provide is the ability with the semantic search to specifically target the relevant content to put into that prompt. So that essentially is why vector databases have become, so hot or a thing. And so really the ability to take your data sources, take an embedding model either from Hugging Face or Cohere or OpenAI and translate or convert that unstructured data, right? Could be a PDF document, can be audio, can be images, videos, and convert it into a vector embedding, which is a numerical representation of that data, store it in a vector database like Redis, and then do a similarity search on it, right? And so therefore, feed only the relevant content into the prompt of the LLM that you're using or have picked to use. And so really the pattern that ties most closely with that is something called retrieval augmented generation, RAG. I believe this is based on a research paper done by some Google folks about 5 years ago. But really, the premise of this pattern or system is really about taking your data and injecting it at runtime into the prompt of that large language model, right? So feeding this external knowledge that your company has that's specific to your domain, storing it in a vector database, and then searching for the relevant or associated content or context to help the LLM generate the right or high quality response. So this is not the same as training it. This is not the same as fine tuning it. You're using the existing large language model, whether it's OpenAI or some others. So let's go to an example because I think this is really critical, and I know we're short on time. So let's assume that in this case, I'm going to use healthcare industry as my example, and someone is going to be asking about what is the proper code for submitting a claim into your healthcare provider, let's say. So you take all your source documents, which in this case would be all of the different codes and associated, relation to the particular disease or symptom. All those things are converted into embeddings. Do some embedding model. The query itself, this particular query that someone asked, what is the ICD-10 code used for common cold, is also using that same embedding model that you converted all your source documents to, and that also is converted into a vector embedding. And then through vector search, in this case through Redis, you're able to find all the relevant content associated with this query and then feed those results into the prompt. And of course, this is a very simplistic diagram. You can use multiple frameworks and code to develop this overall kind of flow to get the data from the vector database and the search results into the prompt. Make sure that maybe you're using some sort of React type template to then make sure that the context and the questions are following a certain format. In this case, we're just going to do a very simple prompt in this case and say, look, given the context below, which is being fed by Redis into your LLM, and then using that specific code and giving them the specific guidance that if you don't know the answer, provide a you don't know, and then taking that relevant context for this question, and then having the LLM now be able to generate a highly relevant, highly accurate response. In this case, it's the ICD code used for common code is J00. Those of you in this particular industry would obviously hopefully validate that is correct, which is classified under the category of upper respiratory infection. So this very simple example, I think, demonstrates the power of RAG and how it can address some of the issues that we see with large language models. So for an example of this, there is a demo of this in our GitHub repo under here. This is the link, and you can look at how we actually did it yourself and actually follow along or modify and do your own testing and prototyping. So getting back to then another part of a RAG system is, well, what if you already know the answer? Let's use a different example. Let's say it's a customer support for I don't know, an appliance or some sort of machinery. And you get the customer support agent gets this question: how do I reset the system after a C384 code alarm is detected? And so the answer is, to recover from it, you press and hold the blue button for 5 seconds, blah, 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 right? And so this has been asked, let's say, many, many times. But it has been asked in a different way each time. And so another example, someone may have used code alarm. Someone might have said condition. Another person may have phrased it this way: the alarm is triggering. How do I turn it off and get back to normal? Well, they all obviously are asking essentially the same question. So we should be able to then be able to cache these questions and also be able to cache the appropriate response or that we already have stored, let's say, in Redis. And so the idea here is that we bypass having to regenerate both the query and the response to the LLM, and we feed it directly from Redis as a vector database because we've already stored those answers. Now we store the questions and the answer to those questions. And by us understanding that each of those different variations in the question is semantically means the same, we're able to then obviously feed that into Redis Enterprise, do the search, and understand that, hey, we already have the answer to this question, and we can now feed it directly to the application to then respond back to the user query. So we give them better user experience because it's much faster to feed it from cache, especially an in-memory data store like Redis. We're able to give you cost efficiency because every call to the LLM is cost money, and so we're reducing the number of API calls that you're doing, and of course not having to wait on the response from the LLM. And so I think I'm probably near my time. And so really the genesis here is that you want to be able to choose a vector database like Redis that is production ready to handle those RAG patterns, the semantic cache patterns, and other things that I didn't talk about today, but things like storing, using Redis as long-term memory to store the entire conversation history with that particular LLM. So having the integrations with tools like LangChain, right, to develop your agents and your chains, if you're using different multiple models, all these things and integrations we have with the leading players in this space, with Llama Index, with Relevance, Meadow, and of course our integration with Amazon Bedrock. All these things enable you to be able to deploy a vector database for those RAG patterns to be able to use your LLMs effectively in your AI application. And we have all of the enterprise goodness that comes from Redis, all the management capabilities, the ability to update those vectors in real time, be able to provide the search results in real time, all the observability integrations that we have to monitor your data in your application, and then of course being able to deploy it using Kubernetes. All these things are all part and parcel of Redis, and we support obviously for the different client libraries. We do have a specific Redis vector library for this vector use case called Vector VL. It's based on our Python library, but it's dedicated and specifically for vector search. And so I just wanted to then close out with, again, reemphasizing the trust that our customers have placed in Redis as a vector database, the performance, the flexibility, and the extensibility. And this is just a quick quote from one of our customers. You may are familiar with Gene, who founded Docuami. He was one of the co-creators of the XML standard. And so really, this was a document use case that allowed Docuami to be able to search and retrieve the proper documents and generate new content for their customers. And that's it. And it's just a last quick reminder, we're going to be at AWS reInvent. And so love to see all of y'all there. If you have any questions around what we do as a vector database and how we integrate to the Amazon Bedrock.